We'll begin our unit on systems of equations with solving 2x2 systems. Possible answers would be where we would have one intersection where it crosses at one point, where we have parallel lines so there's no solution. When we solve, our answer would look like a number and it would not be equal to a number, and infinite solutions, which is overlapping lines. When we solve, it would look like a number equaling a number. This little line through the equal sign over here means not equal to. We're going to solve a system using elimination. The steps are to pick a variable to remove, set up both equations so a variable can be eliminated by multiplying the entire equation, add the equations together and solve for one variable, and plug our found variable back into one original equation and solve for the other variable. Let's start with this system. First, let's pick a variable to remove. In this case, I would like to remove the 3's. So we're going to set up both equations so the variable can be eliminated by multiplying the entire equation by a number if needed. If I eliminate the y's, then I will just have x equals a number. Let's multiply the top equation by -1. Then we draw our line and we combine both equations. 8 minus 5 is 3x. The y's will go away, and -25 plus 19 is -6. Dividing both sides by 3, and x is equal to -2. Now we're going to take the answer that we found in step 3, and we're going to plug it back into an original equation and solve for the other variable. So let's plug it back into the top equation. We're going to plug x equals -2. We're going to plug -2 in for x. And then we simplify. Now we just need to solve for y. So let's add 10 to both sides. And when we divide by 3, y is equal to -3. So the solution is -2, -3. This is an ordered pair, so it needs to be written in parentheses. And then you could check your answer by plugging into both equations to see if it's true. Let's look at another equation. The first thing I want to do is pick a variable to solve for. In this case, I'm going to pick y's again. So what would I need to do to the top equation to make the y's go away? Well, I can multiply the top equation by -3. Now let's rewrite the top equation and rewrite the bottom equation. In the next step, we add these two equations together and solve. Notice that these two go away and leave 0, but on the right hand side, -156 plus 54 is -102. This is not a true statement, it's false, so therefore we have no solution. Let's look at another example. In this problem, let's get rid of the x's. So the first step is to figure out which variable we want to eliminate. Now let's ask ourselves, what do I do to the 2x to make it an opposite pair of 6x? Well, it needs to be a -6x. So let's multiply the equation on top by -3 and rewrite the equation. Rewrite the second equation as well. And now let's draw our line and combine the two equations together. And notice that every one of these on the left side will cancel and give me 0. And on the right hand side, I also get 0. 0 equals 0 is a true statement. So therefore, there are infinite solutions. Now we're going to look at solving a system using substitution. Again, we have some steps. The first step is to solve one of our equations for one variable. Then we plug equation from step 1 into the other equation and solve for the variable. And then we put the answer from step 2 back into one of the original equations and solve for the other variable. Let's look at the equation. X minus 7y equals 11, and another equation, 5x plus 4y equals negative 23. Let's pick an equation to solve for one variable. Remember, look for 1x or 1y if possible. And in this problem right here, I have an understood 1x. So I am going to solve the top equation for one of the variables. I'm going to solve for x. So let's rewrite the top equation and solve for x. Be careful not to add the 7y and 11 together. These are not like terms. So at this point, we're going to take our 7y plus 11, this is the second step, and plug the equation from step 1 into the other equation and solve for the variable. So if we used x minus 7y equals 11 for the first step, then we're going to use the other equation for the next step. So we're going to plug 7y plus 11 in for x and then solve for y. Okay, now that we've substituted 7y plus 11 in for x, we need to distribute 5 to both terms. Now combine like terms. Subtract 55 from both sides, and 39y is equal to negative 78. Divide both sides by 39, and y equals negative 2. So this is the answer from the second step. Now the third step is to take the negative 2 and plug it in to either one of the equations and solve. I'm going to plug it into x minus 7y equals 11, and we're going to plug it into y in this equation. So x minus 7 times negative 2 is equal to 11. So now we have x plus 14 equals 11, and now subtract 14 from both sides, and x is equal to negative 3. So our answer will be written in an ordered pair. The x value comes first in an ordered pair, so x is negative 3, comma, y is negative 2. Of course, don't forget to check the answer by putting in the solution back into both originals and verify. Next example, I have 2x minus 12y equals 3 and negative x plus 6y equals negative 9. Choose an equation to solve for one of the variables. In this case, I'm going to choose the second equation because I notice I have not a positive 1 but a negative 1. So this should be relatively easy to solve for 1x. So let's write this equation down and solve. Subtract 6y from both sides, and we get negative x is equal to negative 6y plus 9. I still have a negative 1 in front, so we are going to multiply the whole equation by negative 1. So we get x equals 6y minus 9. The original equation has a negative 9, so we're going to get x equals 6y plus 9. So here's the answer from the first step. And we take that answer and we plug it into the other equation that we didn't use. So we're going to plug it in for x and then solve for y. Combining like terms, we notice that the 12 y's will cancel, and that leaves 18 is equal to 3. But this is not a true statement. This is a false statement. Therefore, there's no solution. Now let's look at 3x plus y equals 12 and 6x plus 2y equals 24. Let's pick an equation to solve for the variable. We're solving for y, so subtract 3x from both sides. So y is equal to negative 3x plus 12. So there's the answer for the first step. We rewrite the equation that we didn't use for the next step and plug that answer in for y. And we solve for x. Notice in this problem, the 6x's go away and leave us with 24 equals 24. Now this is a true statement, so this answer has infinitely many solutions.